Hi, Algebra 2. This is Lesson 8, Unit 8, Lesson 7, and we're going to do more with the quadratic formula. So I have the quadratic formula listed up here in the top right in case anybody needs it, but this is something that you should be familiar with and be okay using. So let's use it a little differently. Given y equals 16x squared minus 8x, find all the real values of x for which y equals -1. So if y is equal to -1, I'm going to take -1 and I'm going to substitute it in for y. So, let me get a pen. -1 equals 16x squared minus 8x. Now, in order to use the quadratic formula, I have to have it in standard form. So I'm going to bring that -1 over to the other side, and it's going to become +1. So my a is 16, my b is -8, and c is 1. So now I'm going to use my quadratic formula. It's -b, so which is going to be +8, plus or minus b squared. -8 squared is 64, minus 4, a is 16, and c is 1, over 2 times 16. All right, let's clean up that under the stuff under the radical. 64 minus 4 times 16. Well, 4 times 16 is actually 64. Times 1 is 64. So this is just 64 minus 64, which is 0, over 2 times 16, which is 32. So 8 plus 0 is 8, and 8 minus 0 is 8. So there's actually just one solution, and that solution is 8 over 32, which is 1/4. Okay. A second one to try, a little bit different. I want to solve using the quadratic formula. So I'm going to have to distribute that, and that gives me 9x squared plus 3x. Again, standard form means that everything needs to be on one side. So I'm going to bring that 2 over to the left, and it's going to be -2. So then a is 9, b is 3, c is -2. So I got x equals -b, -3, plus or minus b squared. 3 squared is 9, minus 4 times a times c. So 4 times 9, it's -4 times 9 is -36, times -2 is +72, and 72 plus 9 is 81. Oops, I forgot the 2a. Over 2 times a, and 2 times 9 is 18. All right, so this is -3 plus 9, because square root of 81 is 9, over 18, and -3 minus 9 over 18. So let's just simplify that. -3 plus 9 is 6, and 6 over 18 is 1/3, so there's one solution. And then -3 minus 9 is -12, and -12 over 18 reduces to -2/3. All right, so you got the hang of this. We're just solving using the quadratic formula, but I'm going to have to play around with the equation first to put it in standard form. So that's really the only difference from what I was doing yesterday so far. All right, consider the quadratic x squared minus 4x minus 36. Algebraically determine this function's x-intercepts using the quadratic formula. Express your answer in simplest radical form. So a is 1, b is -4, c is -36. So I got -b, which is +4, plus or minus b squared. -4 squared is 16, minus 4, a is 1, and c is -36, over 2 times a. All right, so let's clean up everything under the radical. -4 times 1 is -4. -4 times -36, all right, plus 16 is 160. So anything under the radical, you can really just put into your calculator. Don't put the radical, just put the numbers in your calculator, and then you can see what they are. But you can do 16 minus 4 times 1 times -36. All right, now I had to put this in simplest radical form. So I am going to simplify that radical 160. I'm going to break it down to 16 and 10. And the 16 is the perfect square. That's the one that equals 4. All right, so I'm going to have x equals, let me divide. I meant to divide that. 4 divided by 2 is 2. 4 divided by 2 is 2. And there's my answer. So I got 2 plus or minus 2 radical 10. All right. Express the x-intercepts. Those are the x-intercepts right there. These are my x-intercepts to the nearest hundredth. So in my calculator, I'm going to do 2 plus 2 radical 10. And in my calculator, I'm going to do 2 minus 2 radical 10. So I'm finding these to the nearest hundredth. All right, so 2 plus 2 radical 10, do that in your calculator, is 8.32. And 2 minus 2 radical 10 is negative 4.32. All right, now I can sketch a graph. Using your calculator, sketch a graph of the quadratic on the axis below. And then I'm going to use the 0 command to verify my answers from part B. So basically, one of my zeros is negative 4.32. And the other 0 was 8.32. And then using your calculator, you can see that turning point was at 2, negative 40. All right, so my graph looks something like this. So I'm just doing a sketch. Sketch is not like perfectly accurate or anything like that. Now to confirm the zeros, they wanted me to confirm using the 0 command. So I would have to put that into my calculator, into y1. I put that quadratic, x squared minus 4x minus 36. Hit the graph button. And then basically what you're doing, let me get a pen. You are moving along on this graph. You're going to hit, second, calc, 0. All right. And then remember, you move on the left side. So then you have left bound, you hit enter. And then using the arrows, you scroll down below it, and it's right bound, and enter. And if you're using a regular graphing calculator, they are going to have you hit enter again. It will say something like guess, and you hit enter, and then you will confirm those answers. Okay, and then you do the same thing on this side. Left bound, right bound, enter, enter, and then it will confirm that answer for you. These that we just found. All right, let's see what we got on the back. So which of the following sets represents the x-intercepts? So the x-intercepts are the solutions. So I'm going to use my quadratic formula. All right, so A is 3, B is negative 19, and C is 6. So negative B, 19, plus or minus, and then I have B squared, so negative 19 squared is 361. B squared minus 4 times A, which is 3, times C, which is 6, over 2 times A. So let's clean up anything under the radical. This can just all go in your calculator. 361 minus 4 times 3 times 6. Not the radical, though. Leave the radical for right now. Is 289 over 6. And the square root of 289 is actually a perfect square. The square root of 289 is 17. So I have 19 plus 17 over 6. And I have 19 minus 17 over 6. So that gives me 36 over 6, which is 6. There's one answer. And 2 over 6, which is 1/3. There's my second answer. Okay. Anything that you're not understanding, please make sure that you ask tomorrow. So we got one more to do, and we're going to solve it algebraically and then use my calculator to help me sketch it. So the only thing I really need from that calculator might be the y-intercept or that min or max, that turning point, okay? So I want to find the intersection points of the linear quadratic system shown below algebraically. So basically what I'm going to do is that this is equal to y. So in place of y, I'm going to substitute that. So I have 6x minus 3 equals 4x squared minus 6x plus 2. Again, y is equal to 6x minus 3, so I substitute that in for y in the other equation. So this got substituted in right there. Now, in order to solve this, I need everything on one side. I want to keep the x squared positive, and it's positive on the right, so I'm going to move everything to the right. So I'm going to subtract 6x, that gives me negative 12x, and I'm going to add 3, that gives me 5. So now that I have my A, my B, and my C, I'm going to use my quadratic formula to solve. All right, so negative b, which is positive 12, plus or minus b squared. So negative 12 squared is 144, minus 4 times a, which is 4, times c, which is 5, over 2 times a. So again, this is all on my calculator. 144 minus 4 times 5 is just 64. All right, so this is looking pretty nice so far. Because square root of 64 is 8. So I have 12 plus 8 over 8 and 12 minus 8 over 8. 12 plus 8 is 20. And 20 over 8 is just 5 halves. There's one solution. And the other solution, 12 minus 8 is 4. And 4 over 8 is 1 half. All right, then I'm going to get my graphing calculator out, and I want to find the, so this can be 1 half, and this can be 5 halves, which is 2.5. All right, so I got 5 halves, comma 0, and I got 1 half, comma 0. If you take out your calculator, your turning point was 1.5, comma 4. Oops, 1.5, comma 4. I can also get my turning point. Remember, my turning point is on the axis of symmetry, so it's negative b over 2a. So that's going to be 12 over 2 times 4, which is 12/8. And that's how I got the 1.5, and then I can plug that back in, but you can also see it on your calculator. And I can also see on my calculator, if I look at the table, I can see my y-intercept is 5. All right, so the graph is, it's just a sketch. It's going to look something like that. All right, and just the last thing that's here, the fact that the solutions to the system were rational numbers, okay? Both 5 halves and 1 half is a rational number. It's not a radical. That indicates that I actually could have solved this by factoring. All right, but we were just practicing the quadratic formula here. All right, and we're going to practice some more of that tomorrow.